Yeah, so this is a question from GATE 2017. The question is, the output voltage V0 of the diode circuit shown in the figure is connected to an averaging DC voltmeter. The reading on the DC voltmeter in volts, neglecting the voltage drop across the diode is. So since we can neglect the voltage drop across the diode, we can consider it as an ideal diode. And the question is like, what is the DC output voltage which is measured by a averaging DC voltmeter, right? So here there is one voltmeter and the reading is DC voltage of the voltmeter, right? So here the input is a sinusoid signal and it has a peak 10 minus 10, right? And here there is a clipper circuit diode. So what happens is like during the positive half cycle, right? So I'll just draw the V0. So during the positive half cycle, what happens? The diode is on, right? Here it is plus, here it is minus, so diode is on. So what happens? This is like this node is directly connected to the output like this. So what happens? V0 will be equal to V in for positive half cycle. Okay, so whatever is the positive half cycle input, that you can see at the output V0, right? And what happens during the negative half cycle? So when it is in negative half cycle, this will be minus plus. So what happens? This diode is like open. So there won't be any current flowing through 1K, right? So I will be equal to 0. So what happens? V0 will be equal to 0. So V0 equal to 0 for negative half. Okay, so it will be like this. So again it will be repeated in the next positive cycle like this. And what is the peak? Peak will be 10, right? So this is the V0 and this is what? This looks like a half wave rectified signal, right? Or I'll just write half wave rectifier output. So we know the DC voltage, okay, of half wave rectifier rectified signal. So if the input signal is having a peak of Vm, then the DC voltage of the half wave rectifier output is actually Vm by pi. So here Vm is 10, so 10 by pi. So this is equal to 3.18 volt. So answer is 3.18.